Alright, so got to hear that great song. Got a lot of wisdom from it, right? You won't find treats if you always trick, so be nice. Especially to Mrs. Eastman. She's a wonderful person. But what was the problem with that song? I told you guys it was the first line. It was that line, you won't find fossils in an igneous rock. And it's kind of a common misconception about fossils in igneous rocks. And it's one that makes a lot of sense, too, on a very basic level. What is an igneous rock? It is a rock that forms from magma, right, which is super hot. And most of the time, it also forms underground, right, like granite and peridotite. These are very common igneous rocks, and they form below the Earth's surface. And what's a fossil? It's preserved remains from stuff that was living on the surface. So you ask, how can you possibly create a fossil, preserved remains from like the surface, in a rock that forms from magma underground? And with those two things you can't. And that's why there's this common misconception, this wrong idea that you can never have a fossil in an igneous rock. The problem is that there are igneous rocks that are not intrusive. Intrusive meaning that they form underground. There are igneous rocks that are also extrusive, meaning they form above ground. And you guys all know what these are, right? These are rocks that are formed from volcanoes. And whether that's like a lava flow like basalt in the Hawaiian Islands or someplace like that, or whether it's a giant eruption sending ash and smoke and lava everywhere. And even in these scenarios, it's really rare, right? The flowing basalt is really, really hot. It's lava, which is what we call magma when it's at the Earth's surface. And it's pretty much going to incinerate anything that it touches. So you're not really going to get fossils in that circumstance either. And then there's things like Obsidian, which you guys probably know, which is a volcanic glass. And it cools so quickly that the minerals don't even have time to form. And so you're not going to find fossils really in Obsidian either. But there's something else that happens. And it's during this explosion, those huge like mushroom clouds, for instance, they have a lot of ash. And the ash actually also forms into a rock. And it forms into a rock called tuff. Tuff. And it's the igneous rock that is most likely to have a fossil in it, because it will actually act a lot like a sedimentary rock, which is the rock type that we're so used to finding fossils in. Little bits of ash will come and sprinkle down, and they'll land on top of things, and they'll form a cast around it. They'll actually save an impression of something that they landed on top of, and over years and years and years, they will lithify, which is our geology word for turning sediment or small particles into solid stone. So maybe you guys have at some point heard or researched or learned about Mount Vesuvius and the city of Pompeii, one of our great historical moments where volcano erupts, basically covers an entire city and preserves a whole lot of it. And so that was an area where we actually had a fair number of fossils in igneous rock, and that was some human remains as well as plant remains that we have trapped and encased in igneous rocks. So it is possible. It's not very common. Normal to think most igneous rocks don't. And so really what that song should have been, it could have been one of two things. You almost always won't find fossils in an igneous rock, or you could even go with something like, you won't find fossils in an intrusive igneous rock. And both of those would be more accurate statements. But the statement itself, you won't find fossils in an igneous rock, is slightly incorrect. And why is all this important? Why does it matter? Other than you guys get to watch a video of me being weird in class, is it's kind of all part of the Geologic Record, which is what you guys are going to be talking about. And the Geologic Record is this amazing keepsake of knowledge, kind of like a library, but it's stored just outside, in the earth, in the rocks. And it can tell us a whole lot of things. It can tell us what an environment was like when rocks were forming, where a certain part of the world probably was as a result what the conditions were like. Was it wet there? Was it a volcano in the area? We can learn a lot about the history of the Earth as well as the species that survived during it by looking at the rocks. And it can tell us a lot about not only the history but the common day Earth as well. And that's kind of a cool and powerful thing, that we can determine so much about the world just by looking at the rocks around us. And I'll take a little bit more time in just another second, another video, to talk to you guys about some cool stuff about the geologic record and how it works.